think I just copied it. Let's save that. Oh, I did. Alright, now I don't have to type all that. Again, I already did that once. But let's say you're just starting from scratch. So you launch PowerShell. There we go. And then what you want first is start by saying Java, and then those virtual machine arguments come after Java because they're specific to Java and the virtual machine, not Velma. So that is where I would have my XMX. Here I'll say 4 gig. You know, you need to have whatever you put in there. You need to have that much memory to allocate. Just FYI. Pretty much all machines have 4 gig. And then for running this setup, I'm going to do -cp for class path, which is then informing the Java virtual machine how this Velma jar is going to be ran. And then you can drag and drop. You could drag and drop the Velma jar that you're going to be using, but I actually just copied what I had and pasted it because you need to include a quote on the front and the back. So you actually, if you drag and dropped it, you'd have to then you'd have to arrow over with your keyboard to the front and add a quote. I think you can put single quote, but I like double quote because they're easier to see, because again they're important and they're needed. If you added a penumbra jar for doing radiance work or stream temp, then you could have a semicolon and then include the penumbra jar, and it would be inside this same quote block. And then on the end here we'll add a space. That's important. A single space between all of these various arguments. And then the thing that you always, at least I have to always look up, which is why I was careful to copy this, is then you need, because you said you're going to run this from a class path, after you give it the jar, you then need to tell it that class path location. So for doing this type of work, this varied resolution, you need to run it from the gov.epa.velmasimulator, all lowercase, .velmaparallel command line. So we're leveraging Velma Parallel here. We're just doing some of the work for Velma. And uppercase V, uppercase P, uppercase C, space. And then after that, you then provide your, oops. Sorry, I'm over in Notepad++ trying to copy the correct thing here. I just realized in doing this that I didn't show the details on setting up the XML. There is a couple little details that are important, so we'll do that as well. Sorry about that though, that means we're a little out of order. Man, this thing is being a pain to copy. Trying to copy this text that was really long text line. I'm just trying to get a piece out of the middle. There we go. There we go. So also in quotes is the XML. And then before we do this last bit, well, no, let's just finish the last bit. So if you're allocating a certain number of processors, then that is space, then dash dash, double dash, max processes equals, and then the number. Here I have 4, uppercase P, everything else is lowercase. And then lastly, the last argument provided is that relocation file. So space after the max processes equals 4, little space there, dash dash relocation file, all lowercase except for the F, capital F, equals, and then the fully qualified file path to the CSV file that you created, which is this CSV file that has the index from the flow coming out from the first simulation and the index position and the inflow at my higher res 3-meter floodplain. And then this is a folder path to where the data are from that first simulation. So this is only a folder path location because, again, as we saw earlier, it's not just a single file of data needed, but rather well, I was in that write-up. It's multiple. There we go. It's multiple files needed. All of these here. So that this is pointing to that file set in that folder, wherever you put it. And then that's it. So, as I go over real quick again, Java, I allocated more memory. So dash XMX 4 gig, dash CP, and then in quotes, path to my jar that I'm running, gov.epa.velmasimulator.velmaparallel command line, and then the path to my XML. Max processes, if you don't need to do this, but if your setup would allow you to run more processes. So this is the Velma parallel specific thing, unrelated to this low res flowing into high res. And then the relocation file that you set up. And so there's one key thing here that I missed. I will say, I can just hit enter at this point, and then now it's running. But I've already had these results, and so I'm not going to have my system run this. Just going to hit escape and quit it. But if it runs, then you can just let it go and continue on until it's completed. But what I skipped over, sorry about that, was the XML setup. So how do you make this work on the XML side? So before you set up your PowerShell and your whole command line to run it, you do need to create your XML setup that focuses in on the high-res data. So here in this example, I have my DIM. That's that 843.677, the 3-meter high-res. I need to set my downstream pour point. So this is just typical of all Velma setups, right? So this is the downstream location. For my setup here, that would be where this tolt flows in right before the Snoqualmie. So my pour point would be right here. So that's the pour point I'm referring to here. So this is just to run the floodplain, well, the tolt and the south side of the floodplain itself. The simulation driver data and the number of years you're running, they need to match. So really, you typically focus in on this setup first. I would actually create this setup first so that you're thinking about the timing. But then you need to run the upstream portion with the timing, the day-to-day timing in mind for it flowing into this simulation. And then the other thing you need is I have multiple, so you need to set this to be in multi-mode first. And then I have multiple pour points here, but one of these needs to map to the input contributions that are in my relocation file. And so the pour point here, the data, the inflow location, this location needs to exist in this file set here. If that relocation file number, I don't think it exists here, so I think, sorry about that, it's trying to make this a clean example, but yeah, the high-res cell location where you're feeding the data into from the low-res simulation, it needs to exist in this file set, or this pour point location. Here I have multiple because the rest of these, just FYI, are, whoops, I clicked on it. The rest of those other locations are all of these various subreach pour points for all of these different colors here. So that's why I have more. But you need to have, you're going to end up actually with two. you'll see here that under multi-mode, one of these values in the subreach mapping controls is the pour point. But then you should have at a minimum, actually as a clean example, let's just do this. At a minimum what you would have, I just won't save it. At a minimum you would have your pour point for this setup, and then you would also have the pour point I-index position for in this map, but it's that transferred location from the low-res run feeding into the high-res run. But this I-index location here is for the I-index for this high-res simulation. And so at a minimum, I would need to have these two. That way the data from the low-res run gets fed into this data in this DIMS location on this flow path, and then also the pour point for this simulation. So this is basically the upstream location and the downstream location. Otherwise, all other VelMA aspects need to be set up regarding your coverage maps, and if you want to have any data drivers, and if you want cell data writers, or so this is otherwise, other than the specific thing with the sub-mapping reach controls, everything else would be a normal VelMA setup. And again, I can't stress enough, because I've messed this up several times, you always got to keep in mind doing this, that the upstream data that you run first, any contributing data that's coming in at any pour point, I-index position from prior runs, the low res typically runs, the timing must match. So if you run one simulation for 10 years, then you have to run this one for 10 years. If you want to run this one for 12 years, then you have to redo your first set to match the 12 years. And so VelMA needs, at that, since we're in this simulation, since we're not actually simulating live the upstream part, it's been pre-calculated ahead of time, then the timing of course needs to match so that the flow, there is actual flow data and all the other information that's passed along for each state. So hopefully this was helpful. Ended up being almost an hour, and I think that covers everything. I can easily edit in more info if need be. But yeah, so thanks for watching.